In this video, I want to show just a little quick look at the lab we'll do for PID controls. And PID stands for Proportional, Integral, and Derivative Control. And if you missed class on Monday night, basically this will kind of show you what you'll do in the lab. So PID control, we're basically looking at a closed loop control system where we have a feedback signal coming from from the process. That feedback signal comes back and gets compared against the set point. Basically, the set point is what do we want the level to be. So if we're looking at our tank as our example, we're going to give our tank a set point, and we're going to say go to whatever, go to 5, go to 6, and we want to see this control system bring us up to that set point and kind of get as close to that number as possible without really going too far over it. And next after that is we're going to put what's called a disturbance on the system. So a disturbance would be if we opened up the discharge valve. So if we open a discharge valve, we would get water would start to flow out of the tank and our level is going to drop. So how quick does our control system respond to that and get us back to the set point we want to be at, and kind of keep us at that set point as level as possible. So PID control is going to help us with that. Now, for this lab, we'll do everything's going to be pre-configured and ready to go. There's not going to be a program to have to program or anything to wire up. I got everything kind of set up. So basically, you'll have 3 components to this lab. Component 1 is going to be a CCW program running on the Micro800. So at your workstation, there's a Micro800 controller that basically has this program installed in it. Now, this is something slightly different than what we've been used to. This is what we call function block diagram. And function block diagram is another programming language for a PLC, and it basically shows kind of a flow of information. So in case, up here we have a bunch of move statements, and we're going to basically take, this variable and move it into this variable. So we're just kind of passing information into other variables here. The real magic happens right here at the bottom, where we have our actual PID block. So this is a block in the Micro800 instruction set. It's called PID, again, for proportional integral derivative. And for the PID block to work, we just need to set up some inputs and some outputs from it. So we have the PID enable, which is just simply saying that it's enabled and ready to go. We have the PV, which is the process variable. This is basically the feedback signal. And in this case, we're going to use the float in1, which is our level for the FactoryIO tank. The SP stands for set point. That's basically what do we want to be. What's the value that we want to maintain. The next input is PID auto manual. So this is essentially we're going to put the PID block in auto mode or manual mode. When it's in auto mode or automatic mode, it's going to be basically controlling things. If it's in manual mode, it won't be controlling. CV manual is basically our control variable. And if we're going to be in manual mode, what do we want our control variable to be? The control variable is what is it that we're actually going to control. So going back to our tank here in FactoryIO, we have really 3 things in this scene. We have a fill valve, we have the level sensor, and we have a discharge valve. So in this example, we are going to control the fill valve. And the fill valve is a control valve in that we can control how, what percentage open is it going to be. Is it going to be 100% open, 50% open, 25% open, right? We can throttle it essentially, how much we want that to be open. So that's going to be our control variable. That's the thing that we're going to control. We're not going to control the discharge valve. It's just going to be randomly opened and closed, basically creating what we call a disturbance. So that's just going to be, this is not under our control. We have no control over this discharge valve in our PID loop. The set point will be what we tell it to be, and our process variable will be the feedback that our level sensor is getting from the tank, right? So those are the three main things we need. We need to know the process variable, the set point, and the control variable. The other things we're going to set up here is we're going to set up some limits for the control variable. What are our limits? In this case, we're going to have to set them to be, from 0 to 100. And then the gains. So when we do our PID block, we need to define the gains for each term, the proportional gain, the integral gain, and the derivative gain. And that's what this lab's going to be about, is kind of playing around with those different gain settings and watching how the system behaves. The next input is a PID direction. So there's either a forward acting or a reverse acting. If it's reverse acting, you're going to set this to false. And reverse acting means basically that if you have a positive error, you're going to have to go into the negative to fix that. So in this case, going back to our tank, if we have a set point of 5, and if all of a sudden we're at 7, that means we're at a positive error. We have to reduce the level of the tank to get back to 5. So that's going to be considered reverse acting. That's going to be considered a false input here. On the output side, we have what the control variable is going to be. So basically, this is going to be the output to the fill valve, which is our float out 0. And then we have a couple of outputs for error codes. And then the other piece of the lab, we will work with what's going to be called auto-tuning. So the auto-tune block will actually auto-tune the PID loop for us and tell us what our gains should be. So to use the auto-tune, basically we're going to bring in the process variable, bring in the set point, and then we have some inputs here to control if we're going to start the auto-tune, abort the auto-tune, and then some outputs here based on if it's in progress, if it's done, what's the status, the control variable manual, which would basically be going to be going back into this green block here. And then if it's a auto-tune control, it'll tell us if it's forward or reverse acting. And then it'll give us the gains. So these are the gains. It'll compute the proportional, integral, and derivative gains that we can go ahead and put back into our real PID block when we go back into auto mode. Okay, so that's the program. And again, nothing for you to have to do other than have this running. For this little video, I'm going to use the simulator, but you're going to go ahead and use the real Micro800 controller. So we got the controller, we've got the factory IO scene running, and then the last piece of this is we have an Optix screen that will help visualize everything that's going to be going on here. So all you got to do is open up this Optix project and start the emulator. I'll minimize that. And then here is our Optix screen. So for the lab, you're going to have, let me reset this here. Oh, let me disconnect and reconnect. Yep, there we go. Now everything's cleared out. So we got an empty tank, You're going to type in some gains. There's going to be part of the lab procedure is just telling you, okay, put in some, type in gains. To type them in, you're going to simply click in this space and you're going to enter the number. Over here is the auto-tune stuff. So that'll be part of the procedure. But for right now, you're going to work with just this area and then this set point and the discharge valve settings here. So when it's in manual mode, there's nothing going to happen. We're going to go ahead and switch this over into auto. Then we're going to go ahead and give it a set point. So let's say you set it for 5.1. We will now watch the tank fill. At the same time, you're going to get to see this, this trend chart showing you what's really happening. This trend chart will give you a true visual of how the control system is working. So the orange line is our set point. So that's the orange line is where we want to be. The green line will be the fill valve, and basically how open is it. So the fill valve can be in a position between 0 and 10. So 10 is fully open, 0 is fully closed. So you can see that it went to fully open, and then it quickly kind of backed off there back to 0. You can see the blue line is a tank level. So you can see we went up, but we went over the orange line and we kind of stopped here. So our level is about 7, where we wanted to be 5.1. All right. And then to put what we call a disturbance on the system, you're just going to simply open the discharge valve. So when we do that, we'll see the water level go down. And then eventually we're going to get back below the orange line. And when we get below the orange line, our control system is going to kick in to try to bring the level back up to our set point, which is 5.1 currently. So there we are, went below the orange line. Now you can see the green valve is opening, and it's going to try to catch up and get the blue line back up to the orange line here as quick as possible. But based on what we program here in these gains, all of this gets, that's how all this gets defined. So, how fast does this blue line come up? How far over the orange line does it go? How far under the orange line does it go? So those are the things that when we tweak these numbers, we're going to watch how all this plays out. Now, to change the gain here, we're going to put it back into manual mode. I can go ahead and reset the scene, and I can change a number and then put it back into auto mode and watch it go again. Now, next thing I want to do is I want to do the auto tune. So at some point after you do all these, you're going to do what's called auto tune. So auto tune is that separate little block that was in the logic. I'm going to simply click and hold the start button until that orange light comes on. I can let go of the orange button now. And when the auto tune happens, it's going to actually just do its own thing. It's going to actually fill the tank. It's going to empty the tank. And it's going to try to determine on its own what these settings should be based on what it sees as the response of the system. So it's going to take a few minutes to do this. And as it's doing this, you can watch the auto tune process play out. So now it just stopped it. It's going to let it drain out a little bit. Might actually let it drain out all the way. Because it wants to see, how the system, behaves, what the speed of it emptying and filling actually is. And when the auto tune is done, we'll get a red solid light here, and we're going to get these numbers will show up in our auto tune gains. Once that happens, we'll be able to copy these numbers and paste them over here. Yep, so here we go. We got the auto tune is done. So if I wanted to, I can take this number, I can Control C to copy it, and come back here and paste it. And do that for each one. We'll also have this other item down here, FC, which stands for filter constant. So we'll go ahead and change that in there too. So once we put all the new gains in there, we can go ahead and do the auto tune abort, which will clear that red light out. I can put it back into auto mode, and then we can now watch the control system behave. So that's going to be the essence of the lab. You're going to set up some gains, play around with the set point, play around with the discharge, watch how the system behaves, here up in the trend and make some observations and come up with determining which system looks to be, which settings look to be the best.